What's up, y'all? Today we're finishing the propeller, and I'm super excited for this video because I get to show you one of my all-time favorite tools to use on a 5-axis machine. And Scott actually made this tool in-house on our Walter grinder. And at the end of this video, I'm going to show you exactly how I programmed this finishing operation using Mastercam's unified toolpath. To finish this part, we're using an oval form circle segment end mill. In a previous video, Barry introduced the circle segment lineup with a lens tool, which has a large radius on the bottom of the tool. An oval form tool has a huge radius on the side of the tool, which is called the barrel section, and typically they come down to a ball nose on the tip. These tools have a massive advantage over a typical ball nose tool because the radius is not being limited by the diameter of the tool. The oval form tool we are using today has a 150 millimeter or 5.9 inch radius on the barrel section. That's almost like using a 12-inch diameter ball nose tool, which would be pretty unrealistic. Because this tool has such a big radius, we can take a much larger step down than we could if we were just using a regular ball nose tool. To put this into perspective, the tool we're using today can take a 5 times greater step down but keep the same surface finish than if we were using a 1/2 inch ball nose. This is obviously going to drastically reduce cycle time. Since this tool also has a ball nose tip, it makes the tool even more versatile because we can finish the fillets at the bottom of the fins and we can also finish the hub all with the same tool. Another added benefit of this tool is hidden in the nature of how you use it. Since you're pretty much always forced to tilt the tool with a 5-axis in order for the barrel section to stay in contact with the workpiece, it's actually helping you keep the tool holder away from the wall you're cutting. As a result, you can get away with shorter stick-out lengths, which is going to keep the tool rigid as possible. So as you can see, even with a 75,000 step down, the blades came out beautiful and I couldn't be more happy with it. So the first thing we're going to do to finish this part is we're going to finish the outside profile. And to do that, we're going to swarf mill it. So under swarf machining, we're going to go into the parameters, select our tool, which is going to be a 1/2 inch bullnose end mill, add our feed and speed. And under cut parameters for swarf geometries, we're going to select the outside profile. We're not going to select the face or this back face. Those have already been finished. So all we need is these top 3 radiuses. We're going to hit end selection. And instead of using an automatic strategy, we're going to use a sync with tilt lines. And we're going to check the tilt lines here and go into select them. What we're going to do is we're going to select all the intersection points of all the radiuses. What that's going to do is it's going to morph the tool path from one line to the next, and it keeps the tool axis parallel with the line that it's closest to. That's going to keep our tool away from the vise and away from the table. We hit OK. I'm going to add a small extension of 5 thou to the start and end of the tool path. Under tool axis control, we're going to make sure 5-axis is selected. Everything's good under couch check. For linking, we're using blend spline for small and retract to clearance for large gaps. Under multi-cuts, we're going to add -50 thousandths to this tool shift here. What that's going to do is it's going to extend the bottom edge of the tool past the bottom edge of the surface we're driving. That way we get a full cleanup. Corners is good. Utility, we're going to transform this tool path 3 times at 120 degrees to make sure we finish all 3 blades. And there's our tool path. For our next tool paths, we're going to need a stock model to drive, so I've gone ahead and made that, and now I need to regen it. So the reason why I made this stock model is because of the approach that I took to finish these blades. Originally what I wanted to do was finish these blade walls with a swarf toolpath. But what I found when I got into programming it is that these blades were not created with a ruled feature, so there's a lot of spaces that wasn't going to clean up. So that left me with two choices. I could either use a ball nose tool to machine it with a small step down, or I could take a circle segment tool and do the same thing with a much larger step down. So what we're going to do to finish these walls is we're going to use a unified toolpath. You can also use a morph toolpath, but I can already tell you that this large radius on the back side is going to give us some trouble. So the first thing we need to do is create some surfaces and untrim them. So let's hide our stock model, create a new layer. We're just going to create some surfaces from this model. So go to Surfaces, Surfaces from Solid. We're going to click all four of these here. Hit Enter, hit OK. Now the first thing we need to do here is hide our model, and we need to untrim these two walls. That's going to get rid of this big radius on the back. So go to Untrim and select this surface and then select this surface. And hit OK. Now we can create a curve from these surfaces. Let's go to Wireframe, hit Curve One Edge, select this surface, drag to the top and click again. Now for the lower curve, I'm going to select this blend radius here and go to the top of it as well. We're going to hit OK. And we're going to do the same to this back side. So we'll roll around. This surface, go to the top, add that, and then for the bottom fillet, go to the top of it as well, and hit OK. Now we have our surface and our drive curves. Turn our model back on. We'll go into this unified toolpath. Now I've already created this with a different layer, so we'll turn those on here. We'll go into our parameters for our unified toolpath. And for the tool, a circle segment tool can be found under accelerated finishing. And we're going to use an oval form tool. So we select the one that I have here. The outside diameter is 740 thousandths. It's going to automatically calculate the cutting length. The profile radius is 150 millimeters with a 3 millimeter bottom radius. Now this tool has been turned back to 3.5 inches for clearance, and it's on a 3/4 inch shank. So we hit Finish. We set up our feeds and speeds, and under the Stock tab, we're going to select our stock model that we just created. The reason why we're going to do that is because we're going to drive this surface here, and you can see that the surface is going to cut a lot of air if we don't. So what this is going to do is it's going to trim the toolpath to the model that we have. Let's go to Cut Pattern, and we're going to add two curves and select Morph. The first curve is going to be that upper chain that we created, and the lower curve is going to be the one on top of the blend radius. Hit OK, and for our machining geometries, we're going to select that surface that we created. Hit End Selection, and we're going to use a 75 thousandth step over. Now, depending on what surface finish you want, you can actually go a lot bigger than this, but I'm going to keep it fine in order to keep the surface finish pretty good. We're going to make sure Extend Trim is selected, and under Cut Pattern, we're going to see here, Approximate. We've tightened this tolerance up a little bit for the chaining tolerance to 5 thou. I think it defaults to 100 thou. Extend Trim, we're going to extend both start and end a little bit. We're going to go to Tool Axis Control. We're going to make sure that we're using 5-axis. For the control, we're going to use Surface with Tilt. And we're going to use Follow Surface ISO Direction. I'm going to make sure that the side tilt is at a constant angle, and we're going to use 73.5 degrees. Now I know that sounds like an odd number, but that's pretty close to the tangent point from the barrel section to the bottom of tip radius of our tool. Under Collision Control, we're only going to check against the flute, and we're going to make sure that we tilt the tool if it's violated. We're going to check against the machining geometries and avoidance geometries. And for avoidance, we're going to select the bottom fillet, the floor, and this outside diameter here, all the way around the part. We hit OK. For linking, we're going to use blend spline, retract to clearance area. We're going to use a lead in and lead out. We're going to make sure we have vertical tangent arc selected. Select the parameters that you would like. And under utility, we're going to do the same as we did before. We're going to transform this 3 times at 120 degrees to make sure we get all 3 blades. And we're going to hit OK. And here's our tool path. Now something you'll notice is that even though we're driving this surface here, it's trimmed the tool path to pretty much where the blade is on the model. And that's because we selected that stock model. So now all we need to do is do the same thing to the opposite side. So let's go into our next unified tool path. We're going to keep stock selected. Under cut pattern this time, for the first curve, we're going to select the top curve of this side. Second curve, same thing. We're going to select the top curve of the fillet down here. Now the only thing we need to change here is under collision, we need to remove this face and add everything except this face. We're going to hit end selection. Everything else is going to be exactly the same. Hit OK. Now here's our tool path for the opposite side. And you can see the same thing. It's trimming the tool path to the stock model that we selected. Now we can hide our drive surfaces. Now we're going to go to finishing the fillets in the bottom. To finish these fillets, we're going to use a unified tool path again. So if we go in here in the parameters, we don't have to use stock on here because we're going to actually drive the model itself. For the tool, we're going to make sure circle segment tool is still selected, but this time we're going to use the bottom radius instead of the barrel section. Under cut pattern, we're going to do a same morphing cycle as we did before. For the first curve, you're going to select the top of the fillet. And for the second curve, obviously, we're going to select the bottom of the fillet. Hit OK. Machining geometries, we're only going to select that one fillet. Hit end selection. I'm going to do a max step over of 20 thousandths. I can get pretty big here since my radius of the tool is just pretty much close to this, what the radius is on the actual part itself. Make sure that we have extend trim selected, and under this extend trim we're going to extend the sides instead of the ends this time. So I'm going to go on the start, it's going to go up the side here 25% of the tool and 15% of the tool on the floor. This is going to give us a little bit of overlap between all the tool paths to make sure everything blends correctly. So let's move on to tool axis. We're going to do 5 axis here, but this time we're going to use lines for the tool axis control. I tried to use other things, but it kept digging the tool into the wall and the floor of the part. So to get a little bit better control here, we're actually going to specify the tool axis lines. So if you click this little button here, that's going to ask you to select what lines you want. Now under layer 14 here, I have tilt axis. I've created these lines here. And what this does is it's basically going to do like our swarf milling tool path before, where it's going to morph from one line to the next. So this is pointing in the direction of the tool axis. So we're going to start on this angle here, and by the time the tool gets over to the middle of the part, we're going to be facing this direction here. And likewise, once it gets to the end of the part, we're going to be facing on this angle here. Now we're using a zigzag strategy, so as it comes back, it's going to do the same thing coming back. So it's going to do that going back and forth each time. Now these are going to take a little bit of playing with. All you got to do is create a line here, select to drive it, and then if it doesn't give you exactly what you need, go in and edit that line and kind of move it until you get pretty much what you want. So this takes a little bit of finesse and a little bit of time to get right, but it's well worth it in the end. So we hit OK, and under collision control, same thing, we're going to select the tool only, machining and avoidance geometries. And for avoidance geometries, we want to make sure that we select everything that the tool might come in contact with. Under linking, we're going to use blend spline, retract clearance area again. Under utility, We're going to transform it again 3 times at 120 degrees. I think that's it. We're going to hit OK. So now, if you want to see this tool path, we can simulate this, or backplot it, sorry. You can see that I'm pretty much starting exactly at this. It's a little bit off, but it's pretty close to what that line is here that I first created. It goes around, it gets pretty close to the line that's in the center of the part as the tool axis. And it rotates on around, and it's going to pretty much end at the line at the end of the part. Now it's going to keep doing that as it goes back and forth. Now we need to do the blend radius on the opposite side. And for this side, I've done the same thing. I've created tool axis lines that keep the tool away from the wall. And it gives a little bit more control about how you want the tool to be at each point. Now you can add as many of these or as little as you want. It's up to you. So we've copied this tool path. We're just going to go in here and do pretty much the same exact thing. For the first curve, we've got the top of the fillet. For the second curve, we've got the bottom of the fillet. Machining geometries, we've got the opposite fillet. Now the only thing we have to change here is, so under tool axis, we need to change our lines. We're going to deselect this side and select the lines that are on this opposite side. We're going to hit OK. Under collision control, we're going to make sure that we have this fillet deselected and select all of the stuff that this tool might come in contact with. Enter. Everything else is going to be the same. We're going to hit OK. Now you can see if we backplot this side, it's pretty much the same thing. We're going to follow the tool axis at each one of those points. Again, this is not something that you're going to get right the first time. This is going to be something that you might have to keep playing with in order to get exactly what you want. Now the only thing left is to do the floor. So we're going to use a unified tool path again for the floor. Turn this tilt axis off. So I have this tool path here. We'll go into the parameters, make sure our tool is selected. And under cut pattern, we're pretty much going to do a morph strategy again. Except this time we're going to, for the first curve, we're going to select the bottom fillet curve on this side. We're going to morph it to the opposite side. Very simple. Hit OK. For machining geometries, we're going to select the floor. Hit end selection. Now since we're using the bottom of the tool, and this is a pretty big surface, I'm going to use a 10,000th step over. This should give us somewhere around a 30 finish at least. And we're going to use a zigzag method. I have extend and trim selected. And under that, we're extending the start and end, which is the back portion and the front portion here. And I'm just extending it just a little bit, just to get it a little past our blend area here. And under tool axis control, we're going to make sure 5 axis is selected. And for actual tool axis, we're going to make sure that it's just following the surface. Under collision control, I've got everything selected for the first strategy here, and we're going to tilt the tool, and we're going to just select avoidance geometries. And for the avoidance geometries, we're pretty much going to select the blades and the top of the profile. Hit end selection. And now we're going to add some stock here. We're going to leave 10 thousandths. This is going to make sure that everything about this tool is going to stay at least 10 thousandths away from our avoidance geometries here. Now the second strategy we're going to use is just the flute and the shank of the tool. We're going to use retract along tool axis. And for this one, we're going to select machining geometries and avoidance geometries. And for avoidance, we're going to select the fillets, the back diameter, and the front face. Now what that's going to do is it's not going to keep it away 10 thousandths, it's just going to make sure we don't violate these surfaces. Hit end selection, and under utility we're going to do the same thing. We're going to transform it 3 times at 120 degrees and hit OK. Now that the compressor is done, there's our tool path for the floor. So the part is pretty much done at this point, but I'm going to go one step further and I'm actually going to chamfer all of the edges. I don't like to do any manual chamfering myself, and I know most machinists don't, so whatever I can do inside the CAM software, I'm going to. So what I've done here is I've created a chamfer model. I've just copied the model and I've actually put a 10,000 chamfer all along the outside profile of this part. And we're going to do a simple morph toolpath with this. So we create a morph toolpath, we go into the parameters, we'll select our circle segment tool again, another cut parameters. For the first curve, we're going to select the outside curve all the way around. It's going to go from one side all the way to this other blade. We hit OK. For the second curve, we're just going to click the inside limit. Now we hit OK. For machining geometries, I'm actually going to select all of the chamfer faces that I want to cut. So I've selected all of these faces all the way around to this back side. We hit End Selection. Now I'm going to change the type to determine by number of cuts, and I'm only going to do one cut. Under Tool Axis Control, we're going to use 4 axes. We don't really need 5 axes here. So we're just going to let the tool follow the surface again. And under Collision Control, we're only going to check against the flute of the tool, machining and avoidance geometries. And pretty much under avoidance geometries, I'm going to select everything on the model except for the chamfer. That's going to be controlled with our machining geometries. We're going to hit End Selection. Everything looks good here. Under Utility, we're going to transform it 3 times, 120 degrees. Hit OK. And now that's our chamfering strategy. You can see, you come down here and it's going to keep away from the part. See, we go all the way around the part. And that's all there is to it.